Good afternoon, friends, and welcome to another session of maths classes. So, today we will be doing another very important chapter of maths, which is determinants. As you can see from here, we will be doing the determinants chapter. So, as you all know, this is the chapter which is one of the most important topics for the ISC or the CBSE board exams. So today we are going to discuss this chapter in details, and before going into the chapter, my request is, please, when I am teaching the chapter, please pause and study along with me and note down all the important theorems and the formulas how to deal with this chapter, because this is a fully logical chapter and it does not have anything which you have to memorize. So you have to note down all the very important theorems and the formulas. So let's get started. This is Parijat sir classes. This is Parijat sir classes going on. So as you all know that we are continuing the ISC syllabus and the CBSE syllabus for the maths. I have also uploaded the physics portion of the ISC and the CBSE. So please, if you wish, you can also see the physics chapters which are also uploaded one by one, and that will be a tremendous help to you. So maths and physics, both the chapters I am uploading them. So what you have to do is that you have to keep following the classes so that each and every session of the class you attend and listen to the lectures, because you do not have to make any notes of your own. Including this, I am discussing the very important logics, the numericals, starting from the base. If you don't have the base also, you don't have to worry, because I am starting from zero base level. I am starting from the zero base level. So my request is, please keep following my classes. Please keep following my classes. So let's get started to the topic of determinants. So let me introduce you determinant. See, how does a determinant look? As you can see here, the determinant looks like this, that these are called the row. This is the first row, this is the second row, this is the second column, this is the first column. So this element belongs to the first row, first column. It is always the row into the column, which is called the order of the matrix. So the order is 2 by 2 because it's a 2 rows, 2 columns. First is always the row, then is the column. So 2 by 2 determinant it is. So this element will be called as the first row, first column. This is called the second row, first column. This is the first row, second column element, and this is the second row, second column element. So if you have, similarly, as you can see, this is a third order 3 determinant, as you can see here. So there will be 3 rows and 3 columns. So 3 rows and 3 columns give you order 3. As you can see here, this is the row 1, this is row 2, this is row 3, this is column 1, this is column 2, this is column 3. So this is the first row, first column, second row, this is the first row, second column, this is the first row, third column, this is the second row, first column, second row, second column, second row, third column. This is the third row, first column, third row, second column, third row, third column. So let's get started. As you do not have more than 3 by 3 rows. So let's get started to find the value of a determinant. So how to find the value of the determinant? So please note, to calculate the value of the determinant of the second order, what you have to do, you have to multiply these two, put a minus sign, and then multiply these two. Okay, so this is finding the value of the determinant. Mod A means value of the determinant. Value of the determinant is found by using mod A. Okay, so how to find? Multiply these two first and then put a minus sign, multiply these two. This will give you the answer. Similarly, if you have to find the value of the determinant of order 3 by 3, so let's see how to find. First of all, what you have to do is that you have to put the following signs here, that is a plus, minus, and a plus. Please note, you have to put these values, these signs in these positions. You have to put these signs in this position. So now when I will be choosing 1, then the rule is you cannot choose the row of 1 and the column of 1. So what is left? You cannot choose the row of 1 and the column of 1. So what is left is this. You cannot choose the row of 1 and the column of 1. So what is left? This much. Okay, so that is what I have shown here. Okay, so see, when you choose 1, you have to choose 5, 6, 8, 9. Then when you choose minus 2, when you choose 2, you cannot choose the row of 2 and the column of 2. You cannot choose the row of 2. What is the row of 2? This is the row of 2. What is the column of 2? This is the column of 2. So you cannot choose this. You cannot choose the row of 2 and the column of 2. Clear? So what is left to you? What is left for you to choose is, when you choose 2, you have to choose this and this, which gives you this. Okay, so it is 4, 6, 7, 9. 4, 6, 7, 9. And now you see 2 has a sign of minus, so you put a minus sign here. You have to put a minus sign here. Clear? So next is, we have to choose now plus 3. We have to choose the 3, and 3 has a sign of plus, so here we give a sign of plus. Now if I choose 3, I cannot choose the row of 3. I cannot choose the row of 3 and the column of 3. I cannot choose the row of 3 and the column of 3. So what is left for us? This much. What is left for us? This much. Okay, so this is what I have chosen: 3, 4, 5, 7, 8. So now, so let's see. So this is how I have chosen. When I am choosing 3, I have to choose 4, 5, 7 and 8. And now we are multiplying them. So see how to multiply them. 5 into 9, this into this, minus this into this. This into this, minus this into this. This into this, minus this into this. So this is what I have shown it here, and then when we calculate it, we get the value of the determinant, which is coming 0. This is how we calculate the value of the determinant. So please pause and note the steps how I am doing. Pause and note the steps how I am solving these sums, because if you are not aware of how to calculate the modulus of the determinant, then you will have problems at the last. Okay, when I will be doing the further numericals, then you will be having problems. So this is how you calculate the value of the determinant. Okay, let's move on to the next part. Evaluate this determinant. So see what we have to do. We have to multiply these two, 2 by 2 determinant, multiply these two, which is sine square theta. Then we have to put a minus sign, as I told you. Then multiply these two, which is minus cos square theta. So minus minus plus, and we all know that value of this is 1. Clear? Now another 2 by 2 matrix. So what we have to do? We have to multiply these two first. So here we have done. Then put a minus. Then multiply these two. So here we have done. And now basic calculations. This is the answer. Next is we have to multiply again 2 by 2. So multiply these two. Minus multiply these two. So here we have done. And so please note here that log AB is equal to 1 by log of BA. So using this concept, I have put it here and they cut out. So the answer is 0. Please note this formula which you may require if the determinant is having log. Clear? Next, evaluate this. So this is a 3 by 3 matrix, the determinant. It is a 3 by 3 order determinant. So I told you that first put the sign plus, minus, plus. Now when you choose 2, then you cannot take the row of 2, or the column of 2. So you have to take this much. You have to take this much. Okay, so this is what we have done. Plus 2, so take 2, 3, 1, minus 3. 2, 3, 1, minus 3. Okay, so now when I choose 3, it has a minus sign. So there is a minus here. Clear? So now that means when I choose 3, I cannot choose the row of 3 and the column of 3. So what I have to choose is this much. What I have to choose is this much. So this is what I have chosen here. Next is when I choose minus 2, there is a plus sign. So here it becomes minus and plus is minus 2. So here when we choose, then we cannot choose the row of minus 2. We cannot choose the column of minus 2. So we have to choose this part, and then this is what we have chosen, and then the calculation starts. So now let's see the calculations here. So it is this. So what we have to do is multiply these two. This is minus 6. Put a minus, then it is 3. So here it is. Then calculate, multiply these two. It is minus 3. Put a minus, and this is minus 6, and there is a minus in front. So it becomes plus. Similarly, these two, it gives you 1. Now put a minus in between, and this is minus 4. So minus and minus becomes plus. So this is calculations, and we get the value of this. Okay, so please always remember this into this. Then you have to put a minus, this into this. Please keep note of it. Okay, please keep a note of it always, that it is this into this minus. There is a minus. You have to put a minus. Okay, A1 into, for C here, A11 into A22, and then you have to give a minus. Then you have to do A12 into A21. Please note that here also, everywhere, multiply 5 into 9 minus, then 8 into 6. So there is a minus in between. Clear? So let's see, the next thing is singular matrix. Okay, okay friends, so singular matrix, what is it? What is a singular matrix? If the modulus of A comes 0, if the modulus of A comes 0, it is a singular determinant. It's called a singular determinant or a matrix. Okay, so let's see, let's find out the value of this. So if we calculate it, as you can see, if we calculate this, then we can get the, so if we are calculating this, then as you can see here, let me show it to you. it will be how much? We have to put a plus, minus, plus. As you can see, it will be 1. So we have to take 5, 6. I think, let me see one thing. Yes. So friends, as you can already see here, we have already taken this determinant. Yes, we have already taken this determinant and I have shown it to you, the same thing. We got the result as 0. We got the result as 0. So the modulus of this matrix or determinant is coming 0. So if it is coming 0, we can call it A is a singular matrix. A is a singular matrix. Please note, singular matrix or singular determinant, as whatever we call it, will be possible only when its modulus value is coming 0. Please note this. Okay, singular matrix will be when mod A will be 0. That is called a singular matrix. Okay friends, so now let's see the next part. Find x if A is given. This is a singular matrix. So this is the x. We have to find it, but they are telling that A is a singular matrix, and we know that if A is a singular matrix, mod of A should be 0. So here we are calculating. So first put the signs plus, minus, plus. So if I take 1, then I have to take 2, 1 and 2 minus 3. As you can see, I have taken that. If I take minus 2 and there is a minus, so it becomes plus 2. It becomes plus 2. If I take minus 2, then I have to take 1x and 1 minus 3. Here I have taken. So next is, if I take plus 3, then I have to take this much, which is here. So now calculating it, as we know that we have to multiply first these two, then put a minus, then this. First we have to calculate these two, multiply these two, then minus these two. Multiply these two, then minus these two. So on calculating it, we are getting this. But we know that mod A is 0. So if this is 0, then x is coming minus 1. Clear? X is coming minus of 1. So let's see. Friends, we have to cover up little bit faster because this is a big chapter. So I have discussed here some very, very important numericals, including the concept with every numerical. So please follow with me, and when you are watching it, please stop the video, pause the video, and then you try to do it along with me. Then only you will be able to understand. So I have to cover up little bit faster. Okay. Find x if A is given is a singular matrix. Again, A is a singular matrix. That means mod A should be 0. So here we are calculating mod A. So first is x plus 1. So when I take x plus 1, I have to take this much. As you can see, I have written it here. When I will take minus 3, which is again there is a position of minus, so minus minus plus 3. So here is plus 3. If I take plus 3, then I have to take this much and this much, which is here. Then when I take plus, this is 4 plus 4. So here is plus 4. So I have to take this much. I have to take this much, and which is here. So now, as you can see, first we will multiply these two, then put a minus, multiply these two. So here we have done. Now multiply these two, put a minus, multiply these two. Here we have done. Multiply these two, put a minus, multiply these two. So here we have done, and now we are calculating it. This is a normal algebra. We have calculated this and got here. So either x is 0 or x, this equation is 0. Solving it quadratically, it is using Sridharacharya formula. We are getting it is 3 plus minus root 205 by 2. So these are the values of x of this determinant. Clear? Next, very important term which is called a minor. Very important term. Please note, this is the minor. We are finding the minor of a determinant. What is a minor of a determinant? What is the minor of a determinant? So let's see what is the minor. Suppose A is the determinant. A is given 4 minus 7 minus 3 2. So minor of 4, as you can see, minor, when you are choosing 4, don't choose the row and the column. So what is left? 2. So minor of 4 is 2. Minor of 4 is 2. Similarly, when you are choosing minus 7, don't choose the row and the column. So it is minus 3 left. So it is minus 3. Okay, minor of minus 7 is minus 3. Similarly, when you are choosing minus 3, don't choose the row or the column. So what is left is minus 7. Next, if you are choosing 2, don't choose the row or the column. So what is left? 4. So 2 is 4. So this is how you find the minor of the values of a determinant. Minor of the values of the determinant. Similarly, when you are finding the minor of a 3 by 3, this was a 2 by 2 order determinant or a matrix. Okay, now we are finding 3 by 3, order is 3 order 3 minor. So first of all, when I choose 1, then I told I cannot choose the row or the column. So this is my left over thing. So this is the minor of 1. This is the minor of 1, which is how much? 6, and multiply these two, which is 4. So 6 minus 4, which is 2. This is how we find the minor. Okay, next is if I choose 2, what is the minor? Don't choose the column or the row. So what you have to choose? This and this. So here I have chosen it, minor of 2, which is coming minus 9, and this is minus 2. So minus 9 plus 2, it will become minus of minus 2, which is minus 7. So this is the minor of 2. So this is the minor of 2. Clear? Next is about 3. So don't choose the row or the column. So this is the thing what we have to choose. Here we have chosen. So it is giving plus 12 minus 4, which is 8. So minus of 3 is 8. Minus of 3 is 8. Clear? So next, see, if I want to choose the minor of minus 3, so don't choose the column or the row. So what is left? This, and this. So here we have chosen it, as you can see, and then we calculated, which is 6, and this is minus 12. So 6 minus of minus 12, 18. So this is how we calculate it. Okay, so next choose 2, and we want to find the minor of 2. So don't choose the column or the row, don't choose this. So what is left? 1, 2, this is 3, this is 3. So as you can see here, we have chosen this 1, 2, 3 and 3. So multiply this 3 minus 6, which is minus 3. So the minor of 2 is minus 3. Please keep following the steps. Please keep following the steps. These are little bit confusing, so you have to follow them by pausing your video. Okay, so if I choose minus 1, what is the minor of minus 1? So don't choose the column or the row. So what is left? 1, 2, 2, minus 4. And here we have chosen this 1, 2, 2, minus 4, and we are getting it minus 8. So friends, my request again and again is that please pause your videos to see how the calculations are being done. Otherwise it will be confusing to you. So my suggestion is please pause them. Next is 2. So if I want to choose 2, I will not choose this row or this column. I will choose this much. Okay, so that is what we have done, and we have chosen this here. For 2 I have chosen this, and so it is minus 2 minus 6, which is minus 8. Next is we will choose minus 4. So don't choose this row or the column. So choose this, this, this and this. Okay, and then so let's see how the calculation goes. Here we have chosen for minus 4. So it is minus 1. This is minus 9. So minus 1 minus of minus 9 is 8. Next, the last one is we have to choose about 3. Okay, so it is how much? Don't choose this row or the column. So we are left with this part. Okay, so now, so see, we have chosen it here. So it is 2 and this is minus 6. So 2 minus of minus 6 is 8. So this is how we calculate the minors. And then okay, so this is the way how we calculate the minor of a 3 by 3 order matrix. Clear? Next important term is the cofactor. Now once you can calculate the minors, then the another term which is called the cofactor. So see, you have already chosen the minors. What are the minors? So for 1, so for 1 the minor was 2. For 2 the minors was minus 7. For 3 the minor was 8. So let's see, here we have put, so 2 minus 7 and now 8. Now one thing please note, that when you are writing cofactors, now you have to put the value of the place signs. You have to now put the place signs also. So here we have put, these are the place signs. Now keep putting the place signs. That means they become this. Clear? Next is so let me show it again once more, please. You have to watch them very carefully. Okay, so now we have to choose the minor of -3, 2 and -1. Okay, so these are the, for -3 it is 18, for 2 it is -3, for -1 it is -8. So we have to put them here. This is how we have put we have put here 18, -3, -8, and now we are putting the position values of it. We are putting the, what were the position values? Minus, plus, minus. So here we are putting the position value of them. Minus, plus, minus. So cofactor is just keep writing the minors and now put the position signs. Put the position sign. This is how we get the cofactor of any matrix. We get the cofactor of any matrix. First find the minors. Now put the minors values and keep putting the cofactors, the minors positional signs. Clear? Okay friends, so let's see. Please pause the video and watch it because these are a little bit confusing, so you have to watch it carefully by pausing it, how I am doing it. Clear? Next, prove that this is independent of theta. This is independent of theta. So let's find the value of this. So first we will put the signs plus, minus, plus. Now if I choose x, I told you I have to choose this much. So here we have chosen. Next is, if I choose sine theta, which is having a minus sign, minus position, then we will choose, if I choose sine theta, I have to choose these values. So here what is I have chosen, and sine theta positional value is minus. So here I have given a minus. Okay, so please keep note of all these. Next is, if I choose cos theta, which is having a plus sign, so here is plus cos theta. Now what I have to choose? I have to choose this much. I have to choose this much. Here is what we have chosen. And now our multiplication, our calculation starts. Now our calculation starts. So what is the calculation? This is plus x. Now we have to do minus x square minus 1. Next is minus x sine theta minus cos theta. Next is minus sine theta, and it will become plus x cos theta. So now calculating it, we are seeing that these cut out. We are getting this. Okay, sine square theta plus cos square theta is 1. So they all cut out and it is coming minus x cube, and there is no theta in this final answer. There is no theta. That means we can tell it is independent of theta. It is independent of theta. Clear? Next is properties, which are again a very important part. Properties of the determinants, because whatever sums we will be doing is with the help of the properties. So property number 1, the value of the determinant does not change if its rows and columns are interchanged. If you interchange the row or column, so as you can see, this was the first row, it becomes the first column. Clear? Then this is the second row, it becomes the second column. Then this is the third row, it becomes the third column. So what they are telling is that if you interchange the rows and columns, the determinant's value, what was before and what is now, will be same. Value of the determinant will not change. Value of the determinant will not change. Clear? Second property, if any two rows or column of a determinant are completely alike, completely same. For example, as you can see here, suppose if they are telling that if you interchange or altered, so what we are trying to tell here is that if any two rows or columns of a determinant are altered, it is altered, T-E-R-E-D, altered. That means, see, we are interchanging this row, this column and this row. We are interchanging this column and this row. So they are telling the determinant will remain. So here we have interchanged it. Here we have interchanged them. See. So they are telling the value of the determinant will remain same, but there will be a minus sign. So this is this. Value of the determinant, what it was before, it will now be also same, but there will be a minus sign. Suppose mod A was 4, the value of the determinant was 4. When you interchange these two columns, the value of determinant will become minus 4. Clear? Okay. Now if we change the rows, suppose I interchange these two rows. So here we have changed it, here we have changed it. So they are telling again it will be same. The value of the determinant will remain. If it is mod A, it will become mod of this, but there will be a minus sign in front. So if you interchange any two rows or any two columns, the determinant's value will remain same, only the value will have a different sign. That is the thing. Clear? Next, if any two rows or columns of a determinant are same, the value of the determinant is 0. For example, here see, any two row, this row and this row is same, so the determinant's value will be what? 0. The value of the determinant will become 0. Or suppose this column and this column, as you can see, are same, the value of the determinant will be same. So if any two rows or columns of a determinant are same, the value of the determinant will be 0. Clear? Next, suppose any particular row is multiplied with the same number. So we can take out that number. Or any particular column is multiplied with the same variable, then we can take out that variable. Please keep it note. Okay, if we multiply any row with the same number, we can take it out. If we multiply any column with the same number, we can take it out. Modulus of the product of two determinant will be same as the modulus of the first determinant into the modulus of the second determinant. Suppose A and B are two determinants. First you multiply A and B, then find the modulus. Is same as first you find the modulus of A, modulus of B, then multiply them. Answer will be same. Next is, let's see, without expanding. That means you have to use your properties. Without expanding, evaluate, find the value of this. So we have to use our properties to find the values of this. So let's see. So see how we are using our properties. As we know, this is our first column, second column, third column, first row, second row, third row. So let us see what we can do to simplify this determinant. What we are seeing, see, C1 minus 8C3 means what? Multiply the numbers of the column 3 with 8, subtract it from the first column element and put it in the first column. This means do this operation and put it where? In the first column. So in the first column, what we have to do? The first column minus 8 times the third column. So this is the number. Please watch here. This is my number 41. From here I will subtract 8 times of this. That means 40. So and put it in the first column. So this is the one. Similarly, 79 minus 8 times of 9, which is 72. So this is giving 7 and put it in the first column. Similarly, 29 minus 8 times of 3, which is 24, which is 5. Okay, now you can see here that these two columns automatically become same, and so the answer is 0. So the answer is 0. So see, without expanding, we don't have to expand the whole determinant. We have to use some properties to calculate them. Let's see further some more. Omega is a cube root, is a complex cube root. So we know when omega is a complex cube root, please note here omega cube should be minus 1 and 1 plus omega square should be 0. Please note that. So we have to using these to help. So these are our help. This is our help, because omega is a cube root of unity. Omega is a cube root of unity, complex number. So please keep note that these should be the help given to us. If omega is a cube complex root, then this is our things which is the information about omega. Clear? So now let us apply them. In the first column, what we have to do? We have to add C1 plus C2 plus C3. That means add this plus this plus this and put it where? In the first column. Put it where? In the first column. So 1 plus omega square, you put it in the first column. Okay, and whose value is 0. Similarly, see, omega plus omega square plus 1. So we are doing C1 plus C2 plus C3 and put it in the first column here. Similarly, omega square plus omega, 1 plus omega, add all of them and put it where? In the first column. So here we have put, and now all these values are 0, as you can see. All the values are 0. So please note that if a determinant has any row or column 0, the answer will be always 0. If a determinant has any row or column as 0, then the answer of the determinant will be 0. Clear? So now let's move on to the next one. Show that this determinant's value is 0. So we have to again apply some concept here. We are doing C1 plus C2 plus C3 and putting it in C3. So see, here we are doing, this is C1, C2, C3 and putting it where? In the C3 column. So we have to add now 1 plus B plus C plus A and put it in the third column. Now we have to add 1 C and A plus B and put it in the third column. Now this part is coming common. So see, we have already shown you a property. And the property says, see, this is the property. Let me first show you the property. me show you which property we are using. Here is the property. This is the property that if any particular column you have a common multiple, you can take it out. So using this, we are seeing that in this column, C3 column, this is the common thing, so we can take it out. So what remain is 1 1 1. Now the property says that if two columns are same, the value of the determinant will be 0. Okay, so basically what we are trying to do is that we are trying to take some properties help, and that is why we are doing all these thinking calculations. See, these are the thinking things you have to do. It will not match with any sum. It is according to the sum. You have to apply your brain and think what to do so that I can get some property and apply my answer. So let's see. Show that this is 0. Okay, so again what we are doing, we are adding C1 plus C2 plus C3 and putting it in C1. Now, so here we are adding this plus this plus this, and we are adding on C1, so we will get 0. Similarly, we are adding this plus this plus this, adding on to C1, we are getting 0. Similarly, we are adding this plus this plus this, we are adding them and putting in the first column. So in the first column, see what we are getting. We are getting all the elements as 0, and we know that if any particular row has all the elements 0 or column has all the elements 0, answer is 0. So see, this type of calculation, this type of imaginations, what you can see here, this type of imaginations is the only thing which you have to apply yourself. This is your brain work. This portion is the brain work. Okay, this is what you have to think. What should I do so that I get the help of any property? Next, show that this is coming 0. Okay, so watch here what we are trying to apply. We are trying to apply in C3, we will do C2 plus C3. In C3, we want to do C2 plus C3. That means C2 plus C3. This plus this we will do and put it in C3 here. Then we will do this plus this and put it in C3. Then we will do this plus this, put it in C3. So see, this part becomes common, so it comes out. And now which property we get? That any two columns, if they are same, the answer is 0. Okay, so this is your observation, what to do with the sum, how to do the calculations, in what way should I do the calculations. So by watching the sum, you have to do this. Next is prove that this is equal to 0. So see what property we are applying. R1, in R1 we want to keep what? R1 plus R2. That means we will add this R1 plus R2 and put it in R1. So here, then we will do this R1 plus R2 and put it in R1. This plus this and put it in the R1. So this part comes common, and now we can see again we have two rows same, so the answer will be 0. Any two rows or any two columns of a determinant, if it is same, then the answer of the determinant will be 0. Okay friends, now we have to prove that this is coming 0. Okay, so first see the applications what we are trying to do. in the R1, in R1 we are trying to multiply A times. We are trying to multiply the R1 column A times this column. This column we are trying to multiply. So see, I'm showing you. I'm trying to multiply this, I'm trying to multiply this row A times. Okay, so see what we are doing. So since we are multiplying, we want to multiply this A times. So to adjust it, I have to divide by A. So here we have multiplied it. See, we are multiplying this A times. Similarly, if I want to multiply R2 columns B times, that means this is my R2 column and I want to multiply it B times. So this is how we have written. See, similarly, I want to multiply the R3 columns C times. We have to multiply the R3 columns C times. So if I multiply R3 column C times, I have to adjust it. So here we have adjusted with A and B and C. So this is the adjustment. Please note, these are the adjustments because we have multiplied with A, B and C. Since we have multiplied, so to adjust it, we have to divide them also. Now, as you can see here, ABC, the second column, ABC becomes common. So it comes out. And this becomes 1, 1, 1. Now this ABC and ABC will cut. So now what we are trying to perform here, please watch from here. From the first column, I want to find out, see what we are doing. We are trying to take out one ABC column common from here. We are trying to take an ABC common from here, ABC common from here and ABC common from here. So this is that ABC. So these are the leftovers. Now what we are trying to do after this, in C3 what I want to do, C1 plus C2 plus C3. That means I want to do this plus this plus this and put them in C3. So here. Similarly, this plus this plus this, I want to put it in C3. So here is C3 column. Again, this plus this plus this, I want to add and put it in C3. So here is C3. Now see, this whole portion becomes common. It comes out. So what is left is 1, 1, 1. And now the columns are identical. So the answer is 0. The columns are identical. So the answer is 0. Please watch here. Answer becomes 0. Clear? Next, see. If ABC are in AP, evaluate this. So we know if ABC are in AP, please watch, this is the condition. If ABC are in AP, this is the condition. Okay. So now what we are trying to do is that we are trying to break up the sum. 4, 5, 6, 7, 8, 9, ABC. We are trying to make a second matrix. You see, this is the second matrix and the rest is a second matrix and the. So as you can see that we have made up two matrices here. Okay, and also from the first matrix, as you can see that we have taken the common y. So from the first, as you can see, from every column there is a y common, y common, y common. So there is a y cube common from the first matrix. And now what we are trying to do is, in the first matrix we have done in R2, in the first matrix we have done R2 R2 minus R1, R2 minus R1, and in R3 we are doing R3 minus R2. So watch here what we are trying to do basically. R2 minus R1, R2, so 3 minus 2, and we are keeping it in R2, that is 1. Similarly 6 minus 5, and we will keep it in R2. Similarly 9 minus 8, we will keep it in R2. And in R3 what we are doing, 4 minus 3 we are doing, and then keep it in R3. Then we will do 7 minus 6 and keep it in R3. Then we will do 10 minus 9 and keep it in R3. So as you can see, these two rows has become the same. As you can see here, the rows, the second row, the third row has become same. So the value of this is 0. Now in the second matrix what we are trying to do is, C2 minus C1. Okay, so please watch here, C2 minus C1, that means 7 minus 4, that is 3, and we will keep it in C2 here. Okay, similarly 8 minus 5, which is 3, and keep it in C2. Then we will do 9 minus 6 and keep it in C2, 3. Now as 3 is common from the second column, we can take out 3. So it becomes this. And now what we will do is that we have interchanged the row and column, interchanged the two columns. And when we interchange two columns, I told you the value of the determinant will have a minus in front. The sign of the determinant will change. That means it's a plus, it becomes minus, Clear? Now let us see. We are applying now the concept R2 minus R1 in R2 and R3 minus R2 in R2. So see, what we are doing here is R2, it was 1 minus 1, that is 0, we kept it in R2. Then 1 minus 1, R2 minus R3 minus R2, R3 was 1, R2 was 1. So what we were doing here is, please note here, we did R2 minus R1 and keep it in R2, R3 minus R2 and keep it in R3. So here we are getting it. So we are having 1 0 0, and please note here, whenever you can make 1 0 0, expand with that row or column. Whenever you can make 1 0 0, expand with that row or column. So we will expand along this column. So now put plus minus plus. So how to do that? So here we are taking 1. So when we take 1, we have to take this much. Okay, there is no use of thinking 0 0. So when we take 1, here we have taken. So I will do C multiply these two. So 1 into C minus B, C minus B. Now 1 into B minus A is B minus A, and a minus in between. There should be a minus in between. Calculating this, we are seeing that we are getting this. Now already I showed you that A, B, C, where already I showed you that A, B, C are in AP. That means 2B is equal to A plus C, or A plus C minus 2B should be 0. So now applying it here, this is A plus C minus 2B should be 0. So this is 0. That means the determinant value has come 0. Clear? This is how we solve the sum. Next is, in this sum, evaluate this. So that means by looking into the determinant, you have to understand that this is a determinant in which we have to use the property. So let's see the property. We are applying C1 minus C3 and keeping it in C1, and C2 minus C3 and keeping it in C2. So what we are doing, actually C1 minus C3. So the answer we will keep it in C1. So here. Similarly, 240 minus 198, and we will keep it in C1. Similarly, 219 minus 181, and we will keep it in C1. Okay, so this is how so now we will do C2 minus C3, C2 minus C3, which is 21, and keep it in C2. Similarly, 225 minus 198, 27, and keep it in C2. Similarly, 198 minus 181, which is 17, and keep it in C2. So this is the things we have done. And now what we will do? So now we are applying, after this matrix we will apply this rule, C1 minus 2C2 and C3 minus 10C2. Okay, so watch here what we are doing. C1 minus twice of this, which is 42. The answer is coming how much? 2, and we will keep it in C1. So here. Similarly, twice of 27 is 54. So 42 minus 54 is minus 12. Similarly, twice of 17 is 34. 38 minus 34 is 4, and we will keep it in C1. Okay, so this is done. And next, we are doing what? C3 minus 10 C2. C3 minus 10 C2. Okay, so C3 minus 10 C2, and we will keep it in C3. This is the thing we have to perform. So 219 minus 10 times of this, so 210, and we will keep it in C2. 198 minus 10 times of 27 is coming minus 72. 181 minus 10 times of 17 is coming 11. So this is how we have kept it here. And now we will see which format we can apply. Now we are applying this concept, R1 minus R3 in R1 and R2 plus 3R3 in R2. So let's see. R1 minus R3, that means 4 minus 4, and we will keep it in R1, 0. Similarly, 21 minus 17, and we will keep it in R1, which is 4. 9 minus 11, which is minus 2, we will keep it in R1. Okay. Now we will do this option, R2 plus 3R3. R2, this is R2 plus 3 times of this. So 3 times of 4 is 12. So this minus 12 plus 12 is 0, and keep it in, and we will keep it in R3. Okay. We will keep it in R2. Similarly, 27 plus 3 times of 17, which is coming 78, and we will keep it here. Minus 72 plus 33 is coming minus 39, we will keep it here. Okay, so now you see, we will try to, now these are the facts from here. From 4 and minus 2, I can take a 2 common. So it becomes 2 and minus 1. Clear? And now what we will do is that we will expand it. So watch, please watch here. These two rows now become identical. These two rows becomes identical and the answer is 0. These two rows become identical and the answer is 0. Okay. So our motive is to do some operations. So these are our operations. This is our operation. This is our operation. This. It completely depends on the sum and the numbers. It is not at all having any formula how to apply. It completely depends upon your numbers. Okay, what type of numbers do you have and what property do you want to achieve? Based on that, it will depend. These operations will depend. Clear? Next, let's see the next sum. This is proof that this is equal to this. Okay, so see, again we are using some operations here. What operations? X times of column C1, Y times of column C2, and Z times of column C3. So since we are multiplying some element with every column, so we have to adjust it by dividing with X, Y and Z, because we have multiplied the first column with X, multiplied the second column with Y, multiplied the third column with Z. So we have to adjust them by dividing. Okay, so now these numbers, so first column if you multiply by X, so see this column if you multiply by X, it becomes X. First of all, where is it? Okay, so what we are doing is we have taken this matrix. Okay, so we are multiplying the first column with X, that means this column with X. So what will it become? X, XYZ and X square. Then we are multiplying this with Y, so Y, XYZ and Y square. Then we are multiplying this with Z, so it becomes Z, XYZ and Z square. So as you can see that there is a XYZ common in the second row and we take it out and these two cut out. So the determinant becomes this. Now what we have done is that we have interchanged the second row and first row. So I told you property says if you interchange row and column, there will be a change in the sign of the determinant. So here is a minus sign. And now we are interchanging the second row and the third row. So again there will be a change of the minus sign. It will become a plus sign and it is this. And now, so we have proved that this determinant is equal to this determinant. This determinant and this determinant are same. Clear? Next thing, this is our determinant given here. As you can see, we have to prove this determinant is equal to this. So let's apply some concept. We want to do R1 minus X R2 and put it in R1. R1 minus X R2 and put it in R1. So let's see. This is our R1 and this is R, we will do X of this. Then we will subtract it. Okay, so this in minus X times of this. So here we get this. Okay, similarly this minus X times of this, and here we write it. Similarly this minus of x times of this. So here we write it. And now you can see that 1 minus x square is common, so it comes out. And now we are performing this operation. R2 minus x of R1 and putting it in R2. R2 minus x of R1. So what is R1? X of R1. So from this we will subtract x times of this, which is a. From this we will subtract x times of this, which is c. And from this we will subtract x times of this, which is p. So see, here we got our determinant, which is equal to this. So it is proved. Basically, you have to think about the operations which we have to do. These operations are the things you have to learn. You have to watch very carefully the type of numbers which are there, so that you can make your decision. Clear? Next, prove that this equal to this. Okay, so first of all, see what we are seeing here is we can take an a common from here, a common from here, a common from here, and here is that a. Okay, we can take a b common from here, b common from here, b common from here, and there is our b. We can take a c common from here, c common from here, c common from here, and that is our c. So now what we are doing is, please watch here, we can take a common from here, b common from here, c common from here, and we are getting this ABC. So now what becomes this? And this becomes a square, b square, c square. Clear? And now what we are trying to use this operation. In R1 we will do R1 plus R2. In R2 we will do R2 minus R3. So let us do the first operation. In R1 we will do R1 plus R2. So R1 plus R2, which is 0, and put it in R1. Next is R1 plus R2, which is 0, and put it in R1. R1 plus R2, which is 2, and put it in R1. Similarly, we will do R2 minus R3. R2 minus R3 and put it in R2. Similarly, minus 1 plus 1 and put it in R2, which is minus 2. We are subtracting it. Next is 1 minus of minus 1, which is plus 2, and put it in R2. Now we are doing expanding along the column C1. So what we will do is that when we expand along the column C1, we have to do plus, minus, plus. Okay, the 0, 0 doesn't make a sense. So if I take 1, then I have to choose this much. So it is 0 and this is minus 4. So 0, it becomes plus 4. So 4a square b square. Clear? Next, see friends, prove that this is equal to xy. So let's apply the operation here. First, C2 minus C1. So see, C2 minus C1 and put it in C2 here. Then is C2 minus C1, which is X, and put it in C2. Then is C2 minus C1, which is 0. Put it here. Next operation we want to do, C3, is C3 minus C1. So let's see, C3 minus C1 and put it in C3. C3 minus C1, which is 0, and put it in C3. C3 minus C1, which is Y, and put it in C3. And now we will expand along the first row. We will expand along the first row. So plus minus plus. So if I take 1, I have to take this much, which is xy minus 0, xy, and that is the answer. Okay friends, next, this is a sum. We have to prove that this is equal to this. So let's see our operations, what we are doing. In C2 we will do C2 minus C1 minus C2. So let's check. C1 minus C2, which is 0. C1 minus C2 and put it in C2. Similarly, C1 minus C2, which is x minus y, and put it in C2. C1 minus C2, which is this, and put it in C2. Next, we are applying the operation C2 minus C3 and put it in C3. C2 minus C3. So this is our C2 minus C3, which is 0, and put it in C3. Similarly, y minus z and put it in C3. Similarly, y square minus z square, which is this, and put it in C3. So now we will expand along the first row, because we have got 1 0 0 here. Wherever you get 1 0 0, please expand along that row. Okay, so we know it is a plus minus plus format. Plus minus plus. So we will take only 1. So we will choose this part. Okay, so if I choose this part, one minute friends. Yes, okay. So yes, we will choose now what 1 minute, I think. Okay friends, one more thing, let me show it to you. Please watch one more thing, that is, from here x minus y and x minus y is a common, and from here y minus z and y minus z is a common, so that comes out. Okay, so this is the thing, x minus y and y minus z, and it was x minus y, it comes out. So now we will expand along the first row. So it is plus, minus, plus, and we will take this one. So here we have taken, and this is the ultimate answer we will get. Proved. So let us take the next sum, this, and we have to prove this. So using the operation R1 plus R3 and keeping it in R3. So let's see. R1 plus R3 and keeping it in R3. Similarly, R1 plus R3 and keeping it in R3. R1 plus R3 and keeping it in R1. Okay. So now see, as you can see, this part is the common part in the whole row, so it comes out, and we make it 1, 1 and 1. Okay. Next is, we are doing C2 minus C1. So as you can see, C2 minus C1, this is our C2 minus C1. Okay, it gives you 0, and we will put it in C1. We will put it in C2. Similarly, beta square minus alpha square, and we will put it as beta minus alpha and beta plus alpha here. Similarly, gamma plus alpha minus beta plus gamma, and we will put it here. Alpha minus beta. Now we are trying to do the operations. In C3 we will do C3 minus C2. C3 minus C2. So let's see C3 minus C2. This is our C3 and this is our C2. So 1 minus 1 is 0. Then is gamma square minus beta square. Then is alpha plus beta minus gamma plus alpha. So it comes out to be like this. Now watch here. We can take a beta minus we can take an alpha minus beta common. If I take an alpha minus beta common, so what will it become? See, alpha minus beta common, so this becomes minus of beta plus gamma. Similarly, if I take beta minus gamma common, so what will it become? This will become minus of alpha gamma plus beta, and this is 1. And now we will expand it along the first row, because we got here 0, 0. So again it is plus, minus, plus. So we will choose this part, and now see the calculations. It is coming minus beta, multiply these two, put a minus in between here. So we get this. So that is our proof. Next, see friends, this is a sum and we have to prove that this is equal to this determinant and this determinant is equal to this answer. So let us apply our basic operations here. C1 is A times of C1. We are multiplying the column C1 with A. So we have to adjust with A. So here we are multiplying the column C1 with A. It becomes this. Next we are multiplying the column C2 with B. So we have to adjust with B, 1 by B. So here is the column C2 multiplied with B, becomes this. Excuse me. And next is we have to multiply the column C3 with C. Sorry. And adjust with C. So here is what we are multiplying, this column with C, and it becomes this. So now as you can see that we can take a common A and A. We can take a common B and B. We can take a common C and C. Okay, so this is what is, so what are the things left? A square will become, see, we are taking common, I'm sorry, I've taken common ABC from here. I did not see it here, and here is that ABC. So that becomes 1 1 1 if ABC goes out, 1 1 and 1. Clear? Now, so this will cut out. Now we are interchanging the third and the second row. So the sign will change, there is a minus coming here. And now we are interchanging the second row and the first row. So again there will be a minus coming, so minus minus plus. This will become, this row will go up, this row will come down. So this is our proof. That means we from this determinant we got this determinant. Now from this we have to get this answer. So let's apply the application C1 minus C2 in C2 and see what happens. C1 minus C2, so it is 0, and put it in C2. So here, similarly A square minus B square, which is A plus B into A minus B, and put it in C2. Similarly A cube minus B cube, which is A minus B into A square plus AB plus B square, put it here. Now we are applying the concept C2 minus C3 and put it in C3. C2 minus C3. So here is C2, here is C3. So 1 minus 1 0 and put it in C3 here. Similarly B square minus C square, which is B plus C into B minus C, put it in C3. B cube minus C cube, which is B minus C, B square plus BC plus C square, put it here. Now as we can see from here that we can take something common. Please watch here. I can take an A minus B common from the second column. I can take B minus C common and B minus C common from the third column. So it becomes what? I took a minus b common, it becomes this. Now we are expanding along the first row because we got 1 0 0. We are expanding along the first row, so let us put the values plus, minus, plus, and we will take this part. So this into this, minus this into this, here we wrote. Now opening the brackets and cancelling all, we get the answer. We get our answer. Clear? We get our answer. Okay friends, so let's see the next sum. Let's go to the next sum and see what is there. So here they are telling that if x is not equal to y not equal to z, and this matrix, this determinant is given, prove that x minus x y z equal to minus 1. Okay, so let us, if you follow that, we can break this matrix into two parts. One is using this one and one is using this part. So see, the first matrix which we write is this x, this and 1 plus. Now we are using this and this. So this matrix can be broken like this. Please watch the thing. The determinant can be broken up like this. Okay. Now from the first determinant, from the second determinant, you can see that we can easily take one x common, and one from the first row, y common from the second row, z common from the third row. So here it is. Okay, so now you can see that if I take common, then this is the determinant which it becomes. Clear? So what I can write here, obviously, please watch here, that if I interchange these two rows and these two columns and then again interchange the two columns, we will come to this same determinant. We will come to the same determinant. So taking that determinant common, we can write it like this. If we interchange these two columns, so 1 1 1 will come here. There will be a minus sign here. Again when we interchange 1 1 1 with xyz, again a minus will come. xyz 1 1 1 will come here, xyz will come here, and x square y square z square will come here. So this determinant is now becoming common. So take it common. So we get 1 plus xyz equal to 0. Clear? Now applying this operation, that means in R2 we will do R1 minus R2. In R2 we will do R1 minus R2. So this will become what? 0, and we will put it in R2. Clear? Then we will do x minus y and put it in R2. Then we will do x square minus y square, which is x plus y into x minus y, and we will put it in R2. Next, what we are seeing is that we can take an x minus y common. You see, from the second row I can take x minus y common. So this will come out. From the third row we can take a z minus x common, because we have done this operation. In R3 we are doing R3 minus R1. In R3 we are doing R3 minus R1. So see here, R3 minus R1 is what? 0. Then Z minus X, here we write, then Z square minus X square. So here we write Z minus X and Z plus X. So we take Z minus X common. So here we get the Z minus X. So what is remaining is this. Now expanding along the first column, that means we will put here plus, minus and plus. So for 1 we have to take only this one, and 0, 0 is of no use. So what do we get here? If I expand it, it will be Z minus plus X into this. So now solving it, we get this. Now please watch one thing. We have already declared that X is not equal to Y, not equal to this. So this will not be equal to 0. This will not be equal to 0. This will not be equal to 0. So to make the equation 0, only this has to be 0. Only this has to be 0. That means X, Y, Z is equal to minus 1. Clear? This is how we solve the sum. Next, let's see. So this is our next sum. We have to prove it is coming this. Okay. So see here, we can again break the determinant into two parts using this part. So here we have taken, see, and using this part, here we have taken. So these are our two determinants. Clear? Now, please watch one thing, that from the second determinant, we can take a P common from the third column. So determinant comes out to be this. Also, we can take an X common from the first row, Y common from the second row, and Z common from the third row. So we get PXYZ. So what remains is this. Now we will do one thing, is that we will interchange the row and column. So there should be a sign change. So here it is. And then we will again interchange these two columns. So again there will be a sign change, so it becomes plus. So that this, now see, these two determinants are same, so we take it common. So in the bracket we get 1 plus PXYZ. Correct? So next, see, when we get this, now let us perform such operations. If we do R2 minus R1 and put it in R2 minus R1, that means we are doing Y minus X and putting it in R2. Y square minus X square, we are putting it in R2. And 1 minus 1, we are putting it in R2. Similarly, the second operation is R3 minus R1 and we are putting it in R3. R3 minus R1. So Z minus X, we will put it in R3. Z square minus X square, we will put it in R3, and 1 minus 1, we will put it in R3. So it comes out to be this. Now see, we can take common Y minus X from the R2, Z minus X from the R3. So these are the commons, and this is our determinant. Now expanding along the third column, because we have got 1 0 0 in this part, so it will be plus minus plus. Clear? So now when I choose 1, then I have to choose this part. So it is 1 into this minus y plus x into 1, so it comes out to be this, and then we get the answer. This is how we prove it. So let's see, friends, what is there in the next question. You have to prove that this is coming as 0. So same way, let us break the determinant using, let us break the determinant using this as one part and minus of this as another part. So see, we have taken two determinants. Here we have used this part minus, and here we have used this part. So these are the two determinants. We have broken it up. Clear? Now we are using the operations. What is the operation? In R2 we will do R1 minus R2. So let's see. In R2 we will do R1 minus R2. So from here, this is the first determinant, please. Okay, so here we are operating in R2, we will do R1 minus R2. So R1 minus R2 is 0. Similarly, A minus B, I will keep it in R2. A square minus B square, I am keeping it in R2. Okay, and from here we can see that we can take A minus B common. So here comes A minus B. Similarly, in R3 we will do R2 minus R3. In R3 we will do R2 minus R3. So let's see. First, let me clear this off so that becomes easy for you. Okay, now we will do R2 minus R3. So see, R2 minus R3 is 0, and here we have kept it. Similarly, B minus C. Similarly, B square minus C square. So now we are taking, see, B minus C common, and here is B minus C. So now what the things remain is this. Similarly, see, the same operations we are applying on this, and we are getting the commons. Same operations, we are getting these common, A minus B from the second row, B minus C from the third row. So here is A minus B and B minus C, and this is the second. This determinant also we are doing the same functions, and this is that determinant. Okay, so here is the second determinant, here is the first determinant, and this comes, and now we will expand it along this one along the first column, and this one also along the first column, because we have got 1 0 0. So plus minus plus, plus minus plus. So when we take 1, we have to choose this part. Here also when we take 1, we have to choose this part. So solving the first part we get this, and solving the second part we get this. When we solve it, the answer comes 0. Okay friends, so see, next one is an interesting determinant. It's about the factorial. So first of all, let me tell you what is a factorial. Suppose it is A factorial. So how to write it? It is A into A minus 1 into A minus 2 into A minus 3 and that it continues. Okay, so suppose it is 4 factorial, so it will become 4 into 3 into 2 into 1. Okay, like this. So now let us start. So 10 factorial, how can we write 10 factorial? We can write 10 factorial, this 10 factorial, I am choosing 10 factorial. Now see, the smallest one is 10 factorial. So 11 factorial, how we will write? We will write it as 11 into 10 factorial. Because 4 factorial, we can write it as 4 into 3 factorial. Clear? Similarly, 12 factorial, we can write it as 12 into 10 into 11 into 10 factorial. And now in the second row, the lowest is 11 factorial. So here it is. So 12 factorial can be broken as 11 factorial into 12. 13 factorial can be broken as 13 into 12 into 11 factorial. Similarly, in the third row, the lowest factorial is 12 factorial. So this is the 12 factorial. So 13 factorial can be written as 13 into 12 factorial. 14 factorial can be written as 14 into 13 into 12 factorial. So from the first row, we can take a 10 factorial common. We can take a 10 factorial common. From the second row, we can take an 11 factorial common. From the third row, we can take a 12 factorial common. So what remains is this. Now we are doing this operation. In the second row, we will do R2 minus R1. And in the third row, we will do R3 minus R2. So let's see. In the second row, we are doing R2 minus R1. So 1 minus 1, which is 0. 12 minus 11, which is 1. 156 minus 132, which is 24. Now in the second operation, R3 minus R2. R3 minus R2. So let's see. R3 minus R2, and we will put it in R3, so which is 0. Similarly, 13 minus 12, which is 1. 182 minus 156, which is 26. So we get that the first column is giving us 100. And we know that whenever there is 100, we can expand about that column or row. So now put plus, minus, plus. If I choose 1, then I have to choose only this part. Okay, because that is the advantage of getting 100. You don't have to perform any other operation except for 1. So this is 26 minus 24. So using this, we get the answer. So friends, as you can see that we are solving a lot of numericals, and you have to understand that the type of numericals what we are doing, the operational functions which we are applying, all these operational functions are completely depending on the numerical. The type of numerical which you are doing, it depends completely on that. So there is nothing called memorizing. So please watch how the operations are being performed. Okay, let's see the next sum. It is this. So what we are doing is we are breaking the determinant, this and this. So see how we broke this determinant. Okay, so now taking x common from the first column, taking the x common from the first column, second column, third column, so we are getting x cube. Okay, similarly taking y common from the first column, x common from the second column and x common from the third column, we are getting yx square, and this is what remains. So now what we will do is, please watch here, that in the second determinant we have got here two columns same, 148 and 148. So this determinant value will be 0. This determinant will become 0. And in the next determinant, so only this determinant remains. So in the next determinant we are performing the operations C2 minus C1 and keeping it in the second column. So let's do C2 minus C1 is how much? 0, and put it in the second column. 4 minus 5 is how much? Minus 1, put it in the second column. 8 minus 10 is how much? Minus 2, put it in the second column. So this was the first operation we did. Now we will do the second operation. C3 minus C2. C3 minus C2. That we will put it in the third column. C3 minus C2. So this is C3 minus C2. So that is 0. Put it in the third column. 2 minus 4 is minus 2. 3 minus 8 is minus 5. So see, we got this row as 1 0 0. So now let's apply plus, minus, plus. So for 1 we will take this much part and solve it. It is giving you plus 5 minus 4. So that is the proof. Okay friends, so let's see the next sum says. So here what we are doing is, please watch very carefully. Here our target will be to break the determinant again into two parts using this and this. From here we will break. So see here, please watch. The other parts remain as it is. They remain, this remains. We will take this, and this, which is this determinant, and then we will take this, and this. So here is that determinant, and now we will solve it. So from this determinant, what we are seeing is, watch please, we can take a common from the first column, B common from the second column. So here it will become AB. Okay. So now since the first two columns are becoming identical, so the property says that the value of the determinant will be 0. So this determinant fully cancels out. Clear? So only remains is this determinant. So here is what we are using it. So let's see. So again we are breaking this determinant. Please watch. We are breaking this determinant into three parts. One is using this part, second this part, third this part. Okay, so here are the three determinants, we have used it up. Now we are taking a common from the first column, a common from the second column, a common from the third column. So there is a cube. Sorry, here. Similarly, we can take a common from the first column, a common from the second column, and b common from the third column. So here is a square b. Similarly, a common from the first column, A common from the second column, C common from the third column. So here is A square C. So now please watch one thing, that is, in this, see, we are getting 1 3 6 1 3 6, two columns same, so determinant is 0. Similarly, we are getting 1 2 3 and 1 2 3 column same, so determinant is 0. So only the first determinant remains. So let's see. So this is the determinant only. So now we have to try to operate this determinant now. So let us apply the operations here one by one. Okay. So in the second column we will do C2 minus C1. So C2 minus C1, which is 0. 3 minus 2, which is 1. 6 minus 3, which is 3. Okay. And now in the third column we will use C3 minus C2, because we have to bring 1 0 0. We have to bring 1 0 0. So please watch here, C3 minus C2, which is 0. 4 minus 3, which is 1. And 10 minus 6, which is 4. So now we are expanding. We will expand it along the first row. So let us put plus, minus, plus. So we have to choose this part. So it is 4 minus 3, and the answer is A cube. Clear? So friends, let's see the next sum in this. So we have to prove that this is equal to twice of this. So what we are doing is, we are breaking the determinant into two parts from here, CRZ and APX. So see, similarly, this I am showing you how you will break it. Please watch here. Take this, this and this, that is the first determinant. Next take this, this and this, that is the second determinant. Clear? So now when we have made the two determinants, now let us come to this. We are interchanging the row and column of this and this. So there is a minus sign in front. So see, the rows are these two columns get interchanged, and again these two columns get interchanged. So there will be a minus sign in front. Now we are interchanging these two columns and these two columns. So again they become plus and plus. So this determinant and this determinant value is same. So it is twice of this. Clear? It is twice of this. We have to prove that only, that this determinant is twice of this. Let's see the next one. This is the determinant. We have to prove this. Okay. So please watch the operations, which are very, very important. In the C1 column, we are doing 1 by A times of C1. 1 by A times of C1. That means this column, C1 column, will be multiplied by 1 by A. Since we are multiplying by 1 by A, we have to adjust with A. Since we are multiplying with 1 by A, we have to adjust with A. So 1 becomes 1 by A becomes 1. This 1 becomes 1, this one becomes 1 by A, and this 1 becomes 1 by A. Clear? Next, we are trying to use the operation C2. How? Multiplying that by 1 by B. So we have to adjust it with B. We have to adjust it with B. So multiplying this with B, this is 1 by B. 1 becomes 1 by b, b becomes 1, 1 becomes 1 by b. So this is what we have done. Next is, we will multiply the third column with 1 by c. So we have to adjust with c, third column with 1 by c. So this becomes 1 by c, this becomes 1 by c, and this becomes 1 by c plus 1. Clear? So now, using the operation C1 plus C2 plus C3 and keeping it in C1 column. So what we are doing? We are doing C1 plus C2 plus C3 and keeping it in C1. So here it is. Similarly, this plus this plus this and keeping it in C1. Similarly, this plus this plus this and keeping it in C1. Now see, this part becomes actually common. This part becomes common in the first column. So that comes out. Already ABC was there. That comes out. So this remains. So now, performing this function, our target is to bring 1 0 0 in any column or any row. So we are performing this function R2 minus R1, R2 minus R1 and putting it in R2, that is 0. This minus this, it is 1, putting it in R2. This minus this is giving you 0. Okay. Next is performing the operation this R3 minus R2, R3 minus R2 and keeping it in R3. 1 by b minus this. So it will give you minus 1, keeping it in R3. This minus this will keeping it give you 1. So now see, we can expand it along the first column because we got 1 0 0. So let us write plus minus plus. So we will take this part. So it is 1 minus 0, 1 minus 0. So we got this. Taking LCM ABC, ABC, ABC cuts. So this is our proof. This is our proof. Clear? Next, see friends. If ABC are the roots of the equation, now this is another type of sum in which this is the root of the equations. Find the value of this. First of all, please watch one thing. This is a cubic equation. So sum of the roots, please watch it. Watch here one thing. Sum of the roots of the equation. Sum of the roots of the equation is what? Minus b by a. It is minus b by a. So this equation, if I write it properly, x cube plus 0x square plus px plus q. So sum of the roots is actually coming 0. That means if these are my roots, we know sum of the roots should come minus b by a. Okay, so where is b? B is 0. This is my b. Please note here, my a is 1, b is 0, c is plus p, and this is d. This is my d, this is my c, this is my b, this is my a. So if I do minus b by a plus b plus c will come 0. Okay. Second, let me erase it. Now, second one is the product of the roots. If I take 2 by 2, product of the roots, that is, this is my product of the alternative roots. So the product of the roots formula is product of the roots formula is c by a, and my c is p and a is 1, so that's why it is p. Clear? Now product of all the roots taken together, product of all the roots taken together, that means a, b, c should be minus d by a, and which is d? D is minus q by 1, minus q. Here is the product of the roots. So let us clear it out. Okay, so using these answers, now let us see what to do. So if I solve this particular part, they are telling that if a, b, c are the roots of this equation, find the value of this. Okay, so now my question is that finding the value of this means I have to, if I expand it, that means this, please watch one thing, we have already done the same sum. Here is the sum and the answer came this. Please watch here. Same sum, answer came this. So we are taking the reference of this answer. So the answer is this. And we know ABC is minus Q. This is plus Q. Okay. So putting the values, we get P minus Q. Because already this sum has been solved here. We have already solved this sum. You see here, solved this sum and we got the answer of this sum. We already got the answer of this sum as AB, BC and AB. Here is the answer. We already proved it. So that's why we are not doing it again. So taking the help of that answer, we are showing that product of the three roots came minus Q. Alternate products sum came P. Okay. So this came P minus Q. Next, we have to prove that this determinant is coming this answer. So let's see. So using the operation C2 minus C1 minus C3 in C1. So please watch. C1 minus C3. C1 minus C3. Please watch here. What is the operation we are using? C1 minus C3 and putting it in C1. So watch here. C1 minus C3 and putting it in C1. So we get it like this here. Similarly, C1 minus C3, which is 0. This minus this. Okay. So we will put the values in this column. Next we will do C2 minus C3. So let's see what is C2 minus C3. Let's see what is C2 minus C3. So this is our C2 minus C3, which is 0. Okay, and we have to put it in, we will put it in C3. So we will put it in C2. So here is this 0. Similarly, we will do b square minus of this and put it in C2. So here we did. Similarly, we will do this minus this and put it in C2. So here we did. Okay. So now let's see the next one. So this we got, and now please watch one thing. This will be, if I open it up, this is what b plus c plus a and into b plus c minus a. So b plus c is coming, and this is what c plus a plus b into c minus a minus b. So from the first column we got a b plus c common, a plus b plus c common. Similarly, here it is c plus a plus b and c plus a minus b. So a plus b plus c is coming, c plus a plus b and c minus a minus b. So again we are getting a plus b plus c common. So we are again taking that from the second column and writing it here. Now we are performing the functions. In R3 we are doing R3 minus R1 plus R2. So let's see. In R3 is R3 minus R1 plus R2, this plus this, so this minus this plus this, and we are putting it in R3. So here it is, the answer. Similarly, we will do this plus this, we will subtract it from this and we will get the answer as this. Similarly, we will do this plus this and subtract it from this, we will get the answer of this. Okay. So now please watch one thing. Again we are applying this operation. C1 is multiplied by a times. So we have to adjust, and C2 is getting multiplied by b times. So we have to adjust our a and b. So see, that's why we divided with a and b. So C1 is getting, so this column, this will be getting multiplied with a. So this has become, and this is multiplied with a. So this has become. Similarly, C2. Okay. So this column will get multiplied with b, and this is what we got. Okay. So now, if we now perform the function C1 plus C3 and put it in C1. So let's see. C1 plus C3 and put it in C1, we will get this. Similarly, C1 plus C3 and put it in C1. C1 plus C3 and put it in C1. Similarly, we will do C2 plus C3 and put it in C2. C2 plus C3. Okay. So C2 plus C3 is this. C2 plus C3. C2 plus C3 is giving you this. And this is your C2 plus C3 is giving you 0. Okay. So now from here what we can see, please watch. We can take a common from the first row, and here is that. We can take a b common from the second row, and here is that. And we can take a 2ab common from the third row. Okay, so these are the things which are remaining ultimately. So here we can see that AB and AB will cut, so this will remain. And now expanding along the third row, so we'll put the sign plus minus plus. If I choose 1, then I have to choose this part. So here we have done the multiplication, this into this minus this into this, and we are solving it. We get this is the answer. So friends, these are quite tough sums. So my suggestion will be, please watch them carefully and please try to practice it. Otherwise there is no use. If you do not practice them, there is of no use to all these sums. Clear? Next is this is what we have to prove. So we are applying the operation. In R1 we are doing A times of R1. In R2 we are doing B times of R2. In R3 we are doing C times of R3. So we have to adjust them. That's why 1 by A, 1 by B and 1 by C multiplied. R1 was multiplied by A times. So here is A times, A times, A times. R2 was multiplied with B times. So here is 1B, B and B. And R3 was multiplied with C times. So here is a C, C and C. Okay. So now, so it becomes this. So then, please watch here. Now we can take a common A, first column, B, 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 second column, C, 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 third column, and this is our ABC. So ABC, ABC will cut. Okay. Now, please watch. This sum, what we got, is the sum which we have already solved it. This is that sum. Please watch it. This is that sum which we have already watched it. We have already seen it. So I am not solving it again. Please see, answer of this sum is already given. So if you notice it, the sum is same. This sum is same. So please watch into this, and that's why the answer is written directly. Okay friends, next sum. Let's see. This we have to prove this. Prove that this determinant is equal to this. Now, applying the operations in C1, I will do C1 minus B times of C3. C1 minus B times of C3. So B times of this minus B times of this will give you 1. Similarly, B times of this and this minus this will give you we are doing sorry, I am by mistake I am applying the column rule, row rule. Okay, so In C1 I will do C1 minus B times of this. So B times of this C1 minus that will give you 1. One plus A square plus B square. Correct. Please watch one thing. Okay, so I have to show it here. Okay, so B times of this, so C1 minus B times of this is this. Similarly, B times of this, now this subtracted from B times will give you 0. Similarly, B times of this, now this minus that will give you this. Clear? Okay, so now let's apply the operation C2 plus A times of C3, and I will put it in C2 plus A times of C3. Okay, so this is C2, and A times of this, if I add, then I will get, first let us have to do this, sorry. So this is C2 plus A times of C3 will give me 0. Similarly, C2 plus A times of this will give me this. C2 plus A times of this will give me this. Now please watch one thing. That is, from here I can take something common. 1 plus A square plus B square, 1 plus A square plus B square. Similarly, 1 plus A square plus B square, 1 plus A square. So from the first column and second column I got 2 times. So that is 1 plus A square plus B square twice. It's a square of that, I got it common. So what remains is this. Now applying the operations, R3 minus B times of R1, R3 minus B times of R1. So let's see, R3 minus B times of R1 will give me 0, and put it in R3. Similarly, this minus this is this. Similarly, this minus this, B times of this will give me this. Now expanding along the first column, because I got 1 0 0. So putting a plus, minus and plus, I will take only this part and solve it. So we will get the answer. So friends, let's see the next sum. We have to prove this is equal to 4A square B square C square. So what is my first operation I am doing? That is, R1 is A times of R1. So since we are multiplying R1 with A, we have to adjust with 1 by A. R2 with B times, so we have to adjust with 1 by B. R3 with C times, so we have to adjust with 1 by C. So here is the determinant we got. And now watch one thing, that is, we are taking A common from the first column, B common from the second column, C common from the third column. So when I do this, then this cuts out and this remains. And now we are doing this operation, R1 plus R2 plus R3, we are keeping it in R1. So let's see. R1 plus R2 plus R3. Okay. So this is our R1 plus R2 plus R3, and we are keeping it in R1. Similarly, R1 plus R2 plus R3 in R1. Similarly, R1 plus R2 plus R3 in R1. So now we see that we can take a 2 common from here. 2, 2 and 2. Here is the 2 common. So this remains. And now let us perform the function R2 minus R1 in R2. R2 minus R1 in R2. So let's do R2 minus R1 and keeping it in R2. R2 minus R1, keeping it in R2. R2 minus R1, keep it in R2. Similarly, let's do R3 minus R1 and keep it in R3. R3 minus R1. So this is R3 minus R1. So here is R3 minus R1. R3 minus R1. Okay, so till here we got. Next, watch. From here we see that now if we apply this operation R1 plus R2 plus R3, so we will get these type of calculations. And now expanding along the first row, because we cannot get 1 0 0 here, so we have to expand it. We cannot get 1 0 0 here, so we have to expand it. So when we take 0, I have to take this part, which is 0 minus A4, it will become minus A4. When we take C square, there is a minus. We have to take this and this. So when we cross multiply this, so we get this. And when we take B square, we have to take this part, cross multiply them, putting a minus sign. So we get this. On solving it, we get 4A square B square C square. Clear? Next. See, this is a sum. We have to prove that A plus B plus C is a factor of this determinant. So let us perform this operation first. R1 plus R2 plus R3 and put it in R1. So here you see R1 plus R2 plus R3, put it in R1. R1 plus R2 plus R3, put it in R1. R1 plus R2 plus R3, put it in R1. Now take this as this is becoming the common. So take it outside, it becomes 1, 1, 1. Now we are doing the operations. In C2 we will do C2 minus C1, in C3 we will do C3 minus C2. So let's see. In C2 we will do C2 minus C1, C2 minus C1 and put it in C2. So that is 0. Similarly, C minus B and put it in C1. Similarly, A minus C, put it in C2. So this is over. Next, we will do is C3 minus C2. C3 minus C2, which is 0, and put it in C3. So A minus C, put it in C3. B minus A, and put it in C3. Clear? So now we can easily see that we have got 1 0 0. So we will expand along the first row, and then if we expand it, we will get our answer like this: A plus B plus C. So please watch here. When we perform the operations, we see that this is coming this. Now see, that means in this answer we have got an A plus B plus C, which proves that A plus B plus C is a factor. Which proves A plus B plus C is a factor. Prove that this is equal to this. So let us perform the function multiply C1 with A. So we have to adjust with 1 by A. That means this is multiplied by A, so becomes A square. This is multiplied by A, so becomes this. This is multiplied with A, becomes this. Clear? Now, let us perform the function C1 plus B times C2 plus C times C3 and put it in C1. B times C2, this is B times of this and C times of this, and add it with C1. So here we get. Similarly, B times of this, C times of this, add it with this, we get this. Similarly, B times of this, C times of this, add it to this, we get this. So now you can see that we have got a term common, A square plus B square plus C square. So that is coming out here. Clear? Next we are performing the function operations R2 minus R1. R2 minus R1. So let's see what does R2 minus R1 do. R2 minus R1, it gives you 0. R2 minus R1, it gives you C. We have to put R2 minus R1 in R2. C minus A minus C plus B. Answer will be put in C R2 column, which is this. Next we will do the operation R3 minus R2. R3 minus R2. So let's see. R3 minus R2. This is R3 minus R2 gives you 0. B plus A minus B, which gives you A, and put it in R3. C minus A, which gives you A. Now expanding along the first column, because we got 1 0 0. Okay, so let's see. If I expand along the first column, then this is coming. Please watch here. I can take an A common from the third row. Yes, I can take an A common from the third row. Here is, which will come out. Clear? So here is that A, and this A will cut out. Now expanding along the first column. So putting plus, minus, plus, and we have to choose only this part. Solving it, we are getting this as the answer. Solving it, this is the answer. Now friends, very important type, that is, please watch this, how to do these type of sums in a very shortcut trick. Okay, One is using your operations. The second is if you can apply this concept, it will be much better also and shortcut. So watch here. Let us take A equal to B. Let us take A equal to B. So wherever there is A or wherever there is B, I will put A. So here is B, here is B, I put it A. So see here, when the moment I put A here, the two columns, they become same. That means the determinant should be 0. That means when putting A equal to B, the determinant came 0. That means A minus B is a factor of this determinant. Similarly, if I put B equal to C, B equal to C, if I put B equal to C, please watch here. If I put B equal to C and C equal to A, I will see that again the two columns are coming same and determinant is coming 0. That means they are also the factors. That means I can tell from here that this determinant has got 3 factors. So see how to write, including a multiple. Now we have to find the value of the multiple. So how to do that? For finding the value of the multiple, please watch here. You have to assume some values of A, B and C. You have to assume some values of A, B and C and put it in your original determinant. And this is the determinant. In original determinant we have put it. And in those factor parts also put the values of A, B and C. So expanding along the first column, we are getting this part, this, and in the right side we are getting 2 lambda. So lambda is equal to 1. That means the answer of this determinant will be this. Lambda is taken as 1. Clear? Similarly, prove that this equal to this. So again, let B equal to minus A. So instead of B, wherever you take B, 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 B. So we see that we got this. Clear? We got this. And if we expand through any row or column, we see that determinant's value is coming 0. Determinant value will come 0. And when the determinant value comes 0, that means B plus A should be a factor. Because B equal to minus A, so B plus A is a factor. Similarly, we can show that B plus C is also a factor. Same way, C plus A are also factors of the determinants. So we can write it like this. The determinant, we can write it like this. Now our target is to find the value of K. So what we should do is that we are assuming let A equal to 0, B equal to 1, C, any values you can choose. Put it in the original determinant and on the right side, and on calculate expanding it, we get this side this and this side is this, K is this. Now we have to put the value of K. So we have to find the values of K. So our factors, that means our determinant becomes this. The determinant on solving, the answer comes this, because K is taken as 4. Clear? Next, this is our determinant. We have to show that it is coming 0. Let's apply some operations on it. On C2 we are doing twice C2 minus 2C1. C2 minus 2C1. So this is our C2 minus of 2C1, and we will put it in C2. Similarly C2 minus twice of this is this. Similarly, C2 minus twice of this is this. Okay, so now what we are doing, we are applying the operations C3 minus 3C1, C3 minus 3C1. Similarly, this is C3 minus of 3 times of C1 gives you this. This is C3 minus of 3 times of C1 gives you this. This is C3 minus of 3 times of C1 gives you this. Now what we are doing is apply R2 minus R1 in R2. So first let me make it clear. Okay, so now see here, this is my R2 minus R1 and we are putting it R2. R2 minus R1, putting it in R2. R2 minus R1, putting it in R2. Okay. Now we are applying the operation R3 minus R1. First of all, let us clear it. Okay, so R3 minus R1. So this is our R3 minus R1 and we will put it in R3. R3 minus R1. Put it in R3. R3 minus R1. Put in R3. Okay. So now as you can see from here, then we can take out a minus 2 common. From these, minus 6 common. From these, so what is left is this is 12, and now we will expand it through any column or any row. Okay, so we are trying to expand it along the first column. So we will use plus, minus, plus. Okay, so when I take x minus 2, I have to choose this part, that is 7 minus 6. Clear? Now when we choose minus 1, then we have to choose this part and this part, which is 7 minus 3. And when we choose plus 2, we have to choose this part, which is 2 minus 1. Okay, so now calculating it, we get the answer this. So x equal to 4. So friends, we have completed the full determinant part today, and my suggestion is that please go through the understanding of the operations very carefully, because you have to understand one thing, that these operations which I am highlighting, you cannot memorize it. It is completely depending upon the numerical, the sum, the type of numbers which you are getting, and before applying them, please, you have to be very confident about the theorems, properties of the determinants, because this is a chapter which you cannot memorize, which you cannot guarantee that your applications of the properties and your applications of the theorems will be same with the others. So there is no guarantee of that. Okay, so You have to learn how I am showing the applications in the numericals, then practice along when I am showing this, then only you will be able to understand this chapter. Otherwise not, it is tough. So do not expect it to learn it in one go. So my suggestion is take it in parts. Don't try to understand the whole session in one lot. Try to take 10 sums apart and then please understand. Okay, so it's once again thanks a lot from my side. This is Parijat sir classes going on. Okay, Parijat sir classes. Please spread as much as possible. Spread as much as possible. So because I am making the notes for you, especially class 12. Especially this is class 12 mathematics. I am trying to discuss the maximum type of numericals and all the variety type of numericals, covering up the whole syllabus. This is the full syllabus covered. This is the full syllabus covered both for CBSE and ISC students. So please keep following the classes and like, share and subscribe. Definitely do that. And till then we again meet for another session of the maths or the physics. Okay, so till then it's goodbye and thank you from my side.